Hey, ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 1, Notes 10. So we're going to talk about writing equations. So I know that sometimes word problems can be really tricky for students, so I'm going to try and make it as painless as possible. So what we're going to do is we're going to go over a bunch of word problems, but know that these word problems are very, very similar to the ones on your homework sheet, so I really suggest having that practice sheet out while you work through this, okay? So let's go ahead and take a look at number 1. So it says, after 22 games in 2005, J.D. Drew of the Los Angeles Dodgers had 10 runs batted in. After 36 games, he had 15 runs batted in. Write a linear equation to represent this situation. Okay, so we're going to make kind of a point, so to speak, here. Okay, so what we're going to do is we're going to have a parenthesis that's going to be games and then runs. So let's go ahead and fill out what we have here. So it says after 22 games, why does it never let me draw a 2? Okay, so after 22 games, he had 10 runs batted in. Okay, then after 36 games, he had 15 runs batted in. Okay, so what we're going to do now is we're going to actually calculate out the slope between those two. So I have x1, y1, x2, y2. Okay, so I have y2 minus y1 over x2 minus x1. Okay, so 15 minus 10 is going to give me 5. 36 minus 22 is going to give me 14. So I'm going to go ahead and put this into point slope form. So I'm going to set up my puzzle. Okay, so my slope goes here. That's going to be 5 over 14. Then I need to pick a point. I can use that one or that one. So let's use the point 22, 10. Okay, so in here, the opposite of my y-coordinate. So my y-coordinate is going to be 10, so the opposite is minus 10. Okay, over here, opposite of my x-coordinate. Well, my x-coordinate is positive 22, so the opposite is minus 22. So that right there is your final answer for number 1. Now, let's take a look at number 2. So, number 2, we're going to take a look at this one. As a part-time job, Ethan makes deliveries for a caterer. In addition to his weekly salary, he's also paid $16 per delivery. Last week, he made 5 deliveries and his total salary was $215. So he made $215 last week. Okay? So it tells me we don't know what his total salary was. Okay, we know he made 5 deliveries and was paid $16 for those deliveries. But what we don't know is what his salary was that he got on top of it. Okay, so we're going to have 215, and then we're going to actually take 16 times 5. Well, 16 times 5 is 80 plus x. So what we're going to do is subtract 80 from both sides, and then I end up getting that x is equal to 135. Now it asked us to write a linear equation for this. So first of all, y is going to represent the total we make during the week. So y is equal to, now normally we won't know how many deliveries we made. So I'm going to let x represent the number of deliveries that we made. And he's going to get paid $16 for each of those deliveries. On top of that, he's making his weekly salary of $135. So that right there is the linear equation for that, okay? So let's take a look at number 3. Number 3 says that Ilya and her friends rented a canoe for 3 hours and paid a total of $45. The rate was $10 per hour plus the cost of the daily rate. We don't know what that is, so I'm going to call that R. So we need to figure out what the daily rate is, okay? So she's going 3 hours in a canoe, and the price is $10 for that, plus some daily rate R that we don't know. Now that needs to add up to be the total $45 that we paid at the end. So 3 times 10 is 30, plus R is equal to 45. Okay, so then I'm going to subtract 30 from both sides. So then I get that R is equal to 15. Now this is a word problem and we're actually getting an answer to it, so I need to make sure I label it. So the daily rate is going to be $15. So let's take a look at number 4. It says Yvonne and her friends held a bake sale to benefit the shelter for homeless people. The friends sold 22 cakes on the first day and 15 cakes on the second day. They collected $88 on the first day and $60 on the second day. Let X represent the number of cakes and let Y represent the total number of money made. Find the slope, so just the slope, not the actual line. Find the slope of the line that would pass through the points given. So we're going to have a point x, y, and we're actually going to have 2 of those points because you need 2 points to calculate out the slope. Well, let's take a look. Let's have this first one be the first day. So on the first day, they sold 22 cakes and they made $88. The second day, they sold 15 cakes and they made $60. Okay? So now let's go ahead and let's figure out the slope. So we need to figure out what our y1 is in our. So this is x1, y1, x2, y2. So we're going to do y2 minus y1 over x2 minus x1. Well, 60 minus 80 is going to give me a 88 is going to give me a negative 28. 15 minus 22 is a negative 7. Well, since they're both negative, it's going to become a positive, and 28 divided by 7 is 4. So that's your final answer for number 4. So let's take a look at number 5 here. So your grandmother made 240 ounces of jelly. You have 2 types of jars. The first holds 10 ounces and the second holds 12 ounces. Write an equation that represents the different number of 10-ounce jars X and 12-ounce jars Y. So it assigns us for us. Our 10-ounce is X and our 12-ounce is Y. Okay? So if you think back when I first introduced standard form to you, I told you guys that standard form is used to represent word problems. So all we have to do to write the linear equation is to set this up in standard form. So for every X 10-ounce jar, or so for every X amount of 10-ounce jars we have, it's going to hold, well, 10 ounces. And then for the number of Y 12-ounce jars we have, it's going to hold, well, 12 ounces. Now that needs going to be equal to 240. So this is all you have to do for that problem. That's your answer. Okay, so you have 10x plus 12y is equal to 240. That is a linear equation because it's written in standard form. Doesn't make it not linear. Okay. So let's take a look at number 6. You are buying $30 worth of bird seeds that consists of 2 types of seed. Thistle seed attracts finches and costs $2 per pound. Dark oil sunflower seed attracts many kinds of sunbirds and costs $150 per pound. Write an equation that represents the different amount of $2 thistle seed X and $1.50 dark oil sunflower seed Y that you could buy. Okay, so for every X pound of thistle seed that we get, it's going to cost us $2. For every Y pound of dark sunflower oil, it's going to cost us $1.50, which I can also write as 1.5. Now, we're just going to assume that we're going to spend exactly $30. So that right there is our answer. It's written in standard form and it is ready to go. So let's take a look at number 7, okay? So number 7 says candy corn costs $2 per pound at the candy store and M&Ms cost $3 per pound. With $30 to spend, what are the different amounts of candies that you can buy? So this is going to have to be represented, again, by a linear equation. This is, again, where standard form is going to come in really handy. So I'm going to let X represent candy corn and Y represent M&Ms. So we have $30 that we can spend, okay? For every X pound of candy corn, it's going to cost me $2. For every Y pound of M&M, it's going to cost me $3. And that's my final answer. Remember, standard form is a linear equation. Last but not least, let's take a look at number 8. So it says, suppose you had $6 to buy bananas and apples. Bananas cost 49 cents per pound and apples cost 34 cents per pound. Write a linear equation that represents the different amounts of fruit that you can buy. Okay, so what we're going to do is we're going to say, okay, we have $6 that we can spend. I'm going to let X represent bananas and Y represent apples. So for every X banana that we buy, it's going to be 49 cents. Then, for every Y apple, it's going to be 34. So this is our final answer, is a linear equation in standard form. So that concludes your note video for today. Thanks for listening.